Betelgeuse, the enormous red supergiant closest to Earth, has shown a remarkable decline in brightness in recent years, sparking a wide range of reactions worldwide. Some theories suggest this fading might signal the approach of a supernova, a catastrophic explosion that raises concern among scientists and the general public alike. Betelgeuse, a major star in the Orion constellation, has regained some of its former brilliance after dimming, yet it seems to be entering a phase of reduced activity. Experts are now pondering the future of Betelgeuse and whether its eventual detonation could have any impact on Earth. Orion, one of the most iconic constellations in the sky, is well known for its two primary stars, Rigel and Betelgeuse. The latter, also referred to as Alpha Orionis, is the largest and most luminous star in Orion. Observations made by NASA's Hubble Space Telescope and various other observatories revealed that Betelgeuse underwent an extraordinary mass ejection in 2019, an occurrence never recorded in any star of its kind. Although coronal mass ejections, CMEs, are relatively common with our Sun, this particular outburst from Betelgeuse is unique and has generated significant intrigue among astronomers. This massive burst of mass expelled by the star was 400 billion times greater than the typical CME observed in stars like ours, briefly obscuring some of its light and leading to its unusual dimming. Estimates regarding the distance of Betelgeuse from Earth vary, with some placing it as far as 724 light-years away. The undeniable significance of such an event is clear, but the long-term implications for Earth's environment remain uncertain. As scientists continue to monitor this red supergiant, we can only wait and watch, hoping that the threat, if any, is far off. The outcome of Betelgeuse's eventual supernova explosion would be a stunning sight, but not without significant consequences. The enormous burst of light from such an event would likely be the second brightest object in our sky, right after the Sun. During its peak, it would shine with an intensity so great that it could easily outshine the Moon. This would cause the star to become visible during daylight hours, casting visible shadows in the darkest of nights. The sheer brilliance would captivate observers worldwide. Despite its blinding light, it's important to note that visible light emitted by a supernova accounts for only a small fraction of the total energy produced. The more pressing concern is the high-energy radiation released, typically in the form of gamma rays and X-rays. These forms of radiation are extremely dangerous and have the potential to strip the Earth's ozone layer, a protective shield that prevents harmful ultraviolet rays from reaching the surface. Without this layer, life on Earth would be exposed to dangerous levels of radiation, increasing the risk of a mass extinction event. The aftermath of the explosion would not end with the immediate burst of energy. Cosmic rays, subatomic particles accelerated to nearly the speed of light, would follow, continuing the devastation. Supernovae are among the most powerful events in the universe, and their impact can extend far beyond their immediate surroundings. In addition to the immediate radiation burst, the remnants of a supernova contribute to the cosmic environment by dispersing heavy elements into space. These elements, including iron, gold, and uranium, play a crucial role in the formation of new stars, planets, and even life itself. The death of a massive star like Betelgeuse would therefore be a part of the ongoing cosmic cycle of destruction and creation, fueling the birth of new celestial bodies. The timeline for Betelgeuse's explosion remains uncertain. Some astronomers speculate that it could happen within the next few thousand years, while others believe it may not occur for 100,000 years or more. The unpredictability of stellar life cycles makes it difficult to pinpoint an exact date for its demise. However, observations of its surface activity, variations in brightness, and mass ejection events suggest that it is approaching the later stages of its lifespan. When the explosion does happen, it will provide astronomers with a rare opportunity to study a supernova in unprecedented detail, offering insights into the behavior of massive stars and the physics of stellar explosions. One of the most fascinating aspects of a potential Betelgeuse supernova is its visibility from Earth. Unlike many supernovae that occur in distant galaxies and require telescopes to observe, Betelgeuse is close enough to be seen with the naked eye. The explosion would create a celestial spectacle, lighting up the sky for weeks or even months. During this time, it would be possible to see the remnants of the star even during daylight, making it one of the most extraordinary astronomical events in human history. While the prospect of a nearby supernova is exciting, concerns about its potential effects on Earth remain. Fortunately, most experts agree that the explosion of Betelgeuse is unlikely to pose a direct threat to our planet. The primary danger from a supernova comes from its radiation, particularly gamma rays. However, for a supernova to cause significant harm, it would need to be much closer to Earth, typically within 50 light-years. Since Betelgeuse is over 700 light-years away, its radiation will have significantly weakened by the time it reaches us, reducing any potential risks. Despite this reassurance, studying supernovae remains a priority for astronomers. Understanding the mechanisms behind these powerful explosions can help scientists predict future cosmic events and assess potential threats to Earth. Additionally, research into supernovae contributes to our broader understanding of the universe, including the formation of elements, the evolution of galaxies, and the life cycles of stars. In conclusion, Betelgeuse's eventual explosion as a supernova is an inevitable event, though its exact timing remains unknown. While its recent dimming has sparked speculation, current observations suggest that it may still have thousands of years left before reaching its dramatic end. When it does explode, it will provide an unparalleled opportunity for scientific study and a breathtaking sight for skywatchers around the world. Though concerns about radiation and cosmic effects are valid, the star's distance from Earth ensures that any potential impact will be minimal. As we continue to observe Betelgeuse, we remain on the cusp of one of the most anticipated astronomical events in modern history, a reminder of the dynamic and ever-changing nature of our universe. Despite this reassurance, studying supernovae remains a priority for astronomers. Understanding the mechanisms behind these powerful explosions can help scientists predict future cosmic events and assess potential threats to Earth. Additionally, research into supernovae contributes to our broader understanding of the universe, including the formation of elements, the evolution of galaxies, and the life cycles of stars. Betelgeuse's life cycle is an example of stellar evolution in action. It began as a massive star millions of years ago, burning through its hydrogen supply much faster than smaller stars like our Sun. Over time, as the hydrogen was depleted, Betelgeuse expanded into a red supergiant, beginning the later stages of its stellar evolution. Eventually, the core of the star will collapse under its own gravity, triggering the supernova event. Following the explosion, what remains of Betelgeuse could take different forms. One possibility is that it could leave behind a neutron star, a dense remnant composed primarily of neutrons. Neutron stars are incredibly dense objects, packing more than a sun's worth of mass into a city-sized sphere. Another possibility is that Betelgeuse could collapse into a black hole, depending on the final mass of its core. The significance of Betelgeuse's eventual fate extends beyond the realm of astronomy. Studying supernovae like this one can help scientists refine their understanding of nuclear fusion, stellar death, and the distribution of elements throughout the cosmos. The event will also provide valuable data for improving models of how stars evolve and die, which in turn can inform our understanding of the Milky Way and other galaxies. In conclusion, Betelgeuse's eventual explosion as a supernova is an inevitable event, though its exact timing remains unknown. While its recent dimming has sparked speculation, current observations suggest that it may still have thousands of years left before reaching its dramatic end. When it does explode, it will provide an unparalleled opportunity for scientific study and a breathtaking sight for skywatchers around the world. Though concerns about radiation and cosmic effects are valid, the star's distance from Earth ensures that any potential impact will be minimal. As we continue to observe Betelgeuse, we remain on the cusp of one of the most anticipated astronomical events in modern history, a reminder of the dynamic and ever-changing nature of our universe. Another important aspect of studying Betelgeuse and similar stars is their contribution to interstellar enrichment. The explosion of supernovae is a primary process by which elements heavier than iron are formed and distributed throughout the cosmos. These elements become part of interstellar dust clouds, which later condense to form new stars, planetary systems, and even the building blocks of life. Essentially, the death of one star paves the way for the birth of new cosmic structures, a fundamental process in the continuous evolution of the universe. Technological advancements have enabled astronomers to closely monitor stars like Betelgeuse, providing real-time data on their activities. Space-based observatories like the James Webb Space Telescope and ground-based telescopes equipped with adaptive optics allow for unprecedented precision in observing the changing dynamics of these stellar giants. These tools help scientists identify the key precursors to supernovae, potentially allowing future predictions of such cosmic events with greater accuracy. Additionally, understanding supernovae has broader implications for astrophysics and cosmology. The explosion of massive stars is one of the fundamental mechanisms shaping galaxies. The energy released by supernovae can trigger the formation of new star clusters, influence galactic evolution, and even affect large-scale cosmic structures. By studying Betelgeuse and its eventual supernova, scientists can gain deeper insights into these processes, refining our knowledge of the universe's grand design. In conclusion, Betelgeuse's eventual explosion as a supernova is an inevitable event, though its exact timing remains unknown. While its recent dimming has sparked speculation, current observations suggest that it may still have thousands of years left before reaching its dramatic end. When it does explode, it will provide an unparalleled opportunity for scientific study and a breathtaking sight for skywatchers around the world. Though concerns about radiation and cosmic effects are valid, the star's distance from Earth ensures that any potential impact will be minimal. As we continue to observe Betelgeuse, we remain on the cusp of one of the most anticipated astronomical events in modern history, a reminder of the dynamic and ever-changing nature of our universe.